Hello everyone. Today we're going to talk about something that can sometimes feel a little intimidating. Math. Many people believe that you are either a math person or you are not. I'm here to tell you that this idea is simply not true. Everyone, and I mean everyone, has the ability to learn and succeed in mathematics. It is like learning a new language or a musical instrument. It takes practice, patience, and the right mindset. The journey might have its challenges, but the feeling of solving a difficult problem is one of the most rewarding experiences you can have. This guide is designed to give you the tools you need to start that journey with confidence and curiosity. Think of math not as a list of rules to memorize, but as a giant interconnected puzzle. Each concept you learn is a new piece of that puzzle. One of the biggest traps in learning math is focusing only on memorizing formulas and steps. You might learn how to solve a specific type of problem, but if you do not understand why the method works, you will be lost when the problem changes slightly. True math success comes from understanding the core concepts. Think about it like following a recipe. If you only memorize the steps, add flour, add sugar, bake at 350 degrees, but if you understand why you add baking soda, to make it rise, or why you cream the butter and sugar, to add air, you can start creating your own recipes and fixing problems when they occur. Math is the same. Let's take a simple example. Finding the area of a rectangle. The formula is area equals length times width. Imagine a rectangle that is 4 inches long and 3 inches wide. You can visualize this as a grid, 4 columns, 3 rows, so multiply 3 times 4 to get 12 squares. This is why the formula works, a fast way of counting all the little squares. Mathematics is a cumulative subject. Everything you learn is built upon what you have learned before. You cannot build a strong, tall skyscraper on a weak foundation. In the same way, you cannot expect to master algebra if you are not comfortable with arithmetic. Basics, addition, subtraction, multiplication, division, are your alphabet. Fractions, decimals, percentages are your simple words. Algebra is like forming sentences. Each step is crucial. Each step is crucial. For example, if you are struggling with simplifying fractions, the problem might not be with fractions at all. The real issue might be that you are not fully confident with your multiplication tables. By going back and practicing your multiplication facts until they are automatic, you will find simplifying fractions becomes much easier. Learning math is a lot like training for a sport, or learning to play a musical instrument. You cannot become a great basketball player by only practicing once a month. You cannot become a skilled pianist by practicing for 5 hours one day and then not touching the piano for 2 weeks. The key to building skill and muscle memory is consistent, regular practice. The same is true for your math muscle. Practicing a little bit every day is far more effective than one long, exhausting study session right before a test. This approach, known as distributed practice, helps move information from your short-term memory to your long-term memory. We are not talking about hours and hours of work. Even just 10 to 15 minutes of focused practice each day can make a massive difference. This short daily session keeps the concepts fresh in your mind and prevents you from forgetting what you learned in class. For example, if you are learning about solving linear equations like 2x plus 5 equals 15, do 5 practice problems today, then do 5 different ones tomorrow, and 5 more the day after. By the end of the week, you will have solved 35 problems. Anyone can find 10 minutes in their day. You can make this a simple habit. Maybe you do your practice right after school, or before you start playing video games. The key is to make it consistent. One of the most powerful and effective ways to deepen your own understanding is to try to explain it to someone else. This is called the protege effect. When you know you have to teach something, your brain organizes the information more logically. You move beyond recognizing facts into true comprehension. Think about how to structure the explanation. Decide the key points. Make it simple enough for someone else to understand. You don't need a formal student, a friend, a family member, your dog, or even a stuffed animal. Speaking the explanation out loud is what matters. Find your mom or dad and ask, "Hey, can I try to explain something I learned in math today?" Walk them through it. Say you just learned to calculate slope. Slope is like the steepness of a hill. It's rise over run. See how much the line goes up or down, then divide by how much it goes across. As you explain, you might get stuck. That hesitation is golden. It's a signpost to what you haven't mastered. It tells you what to review. Once you refine your explanation, next time you're clearer and your understanding is solidified. This technique forces you to simplify and organize. You can't use complicated jargon for a novice. Find analogies and use simple examples. After your next math lesson, find a listener. Teach them the main idea. You'll be surprised how much clearer it becomes for you. In helping someone else, you become the biggest beneficiary. You will move from recognition to true comprehension. Our brains are incredibly visual. For many people, abstract numbers and symbols on a page can be confusing. A great way to overcome this is to translate the abstract problem into a concrete picture or diagram. Drawing the problem helps you see what is actually going on. It can reveal relationships and pathways to a solution. Think about a word problem. A train leaves the station and travels east at 60 miles per hour. 2 hours later, a second train leaves the same station at 90 miles per hour. How long will it take for the second train to catch up? Draw a simple line for the track, make a dot for the station, draw the first train moving along the line. Since it travels for 2 hours before the second train starts, it has a head start of 120 miles. The second train is 30 miles per hour faster, so it closes the gap at 30 miles per hour. Divide 120 by 30 to get 4 hours. Drawing the picture transformed a confusing paragraph into a simple distance rate time problem. This strategy works for geometry, draw shapes, fractions, draw pizzas or chocolate bars, and percentages, draw a 100% bar and shade the portion. Do not worry about your drawing being perfect. A few simple lines, circles, and labels are all you need. The goal is to take the problem out of the abstract realm of numbers and bring it into the concrete visual world your brain is good at navigating. This makes difficult problems easier to see and solve. Start drawing. You'll be surprised how often a picture is the shortest path to the answer. One of the biggest emotional barriers to learning math is the fear of making a mistake. In many classrooms, getting the wrong answer is seen as a failure. But I want you to completely change your perspective on this. Mistakes are not failures. Mistakes are an essential, unavoidable, and incredibly valuable part of the learning process. Your brain actually grows when you grapple with a mistake. Think about how a baby learns to walk. The baby falls hundreds of times. Each fall teaches something. When you get a problem wrong, don't just erase it and move on. Stop and investigate. Be a detective. Where did you go wrong? Was it a simple calculation error? Did you misunderstand the question? Did you apply the wrong formula? For example, 4 times the quantity x plus 2 equals 20. A common mistake is to distribute the 4 incorrectly. If you misdistribute, you might write 4x plus 2 equals sine 20 and get the wrong answer. Instead, multiply 4x plus 8 equals sine 20, then 4x equals sine 12 and x equals sine 3. Checking works. The mistake taught you the distributive property. When you get homework or a test back, spend more time studying the problems you got wrong than the ones you got right. The red marks are not a judgment of your ability. They are a personalized guide to what you need to focus on. Embrace every error as a clue. This mindset shift removes fear and anxiety and replaces it with curiosity and resilience. Every expert has made more mistakes than a beginner has attempted. Remember, the only true failure is the failure to learn from your mistakes. Have you ever looked at a long, complicated math problem and felt completely overwhelmed? It can feel like trying to climb a giant sheer cliff face. The secret: don't look at the whole cliff at once. Find the first small handhold. Break the big problem into smaller, manageable steps. Each small step is a puzzle you can solve. Let's look at a multi-step word problem. You go to a store with $50, a pair of jeans for $28.50, 3 pairs of socks at $2.25 each. Step 1, total cost of the socks. 3 times $2.25 equals $6.75. Step 2, subtotal is $35.25. Step 3, convert the percentage to a decimal. 8% is 0.08. Multiply to get $2.82 tax. Step 4, final total $38.07. Step 5, do you have enough? You have $50, total is $38.07. Yes, you have enough. By breaking the problem into 5 small steps, it becomes manageable. Each step was just a basic calculation. This works for word problems and complex algebraic proofs. When faced with a big problem, take a deep breath and ask, what is the very first thing I can figure out? Do that one thing. Then ask, what's the next logical thing to do? Keep taking one small, manageable step at a time. In a math class, it can be scary to raise your hand and say, I don't understand. You might worry you're the only one lost, or that people will think your question is silly. But here is a secret. At least 5 others have the same question. Asking is not a sign of weakness, it is a sign of strength and engagement. The most successful students ask the most questions. Your teacher is there to help you. They want you to succeed, but they cannot read your mind. Be specific. Instead of "I don't get it," pinpoint your confusion. "I understand line 2, but why did we divide by 3 in the next step?" This helps your teacher give a targeted explanation. Asking questions isn't limited to class. If you're doing homework and get stuck, don't just stare in frustration. Write down your question and circle the problem. The next day, ask your teacher about that specific problem. Ask your classmates for help. Study groups can be incredibly beneficial. Hearing a peer explain something differently can make it click. There is no such thing as a stupid question. Every question is a tool to build solid knowledge. Being curious is the engine of learning. Make a promise to yourself. In your next math class, if a concept feels fuzzy, be brave and raise your hand. One of the most common questions students ask is, "When will I use this?" It's a fair question. The truth is, math is everywhere. In sports, video games, music, cooking, and architecture. If you are a basketball fan, calculate shooting percentage. Shots made over shots attempted, shown as a percentage. If you bake, math is used when you measure and scale recipes, multiplying and dividing fractions. Make these connections and math will feel meaningful. After you have put in the hard work, practicing, making mistakes, asking questions, it is important to look back and see how far you have come. Reviewing consolidates knowledge and builds long-term retention. A weekly check of past work is powerful. Create a mistake journal. Write problems you found challenging, note the mistake, and write the correct solution in your own words. This becomes your personalized study guide. Review it before tests for efficient improvement. Reward yourself for effort and progress. An episode of a show, extra game time, or a treat. Positive reinforcement creates a helpful feedback loop. It associates hard work with pleasant outcomes and keeps you motivated. We have covered 10 powerful tips, from understanding the why to rewarding your progress. These are not tricks, but a way to think about mathematics. They are tools to build a strong foundation and see connections to your life. Remember learning to ride a bike? Wobbles, a few falls, but you kept trying, practiced balance, and eventually it clicked. Math is the same. Initial wobbles are part of the process. Each problem is like pushing the pedals. Each mistake is an adjustment to your balance. Choose 1 or 2 tips and start today. Don't try to do everything at once. Start small and build the habit of daily practice. Teach a concept to a friend. Ask a question in class. Draw pictures. Be patient with yourself. Your brain is a muscle. It gets stronger with challenge. You have the ability to succeed. Believe in your potential. Embrace the journey. With practice and persistence, you can and will unlock your math success. You can learn anything. Let's begin. Choose 1 tip and start today. You can do this.